So today we'll be looking at an overview of ecology, then looking at energy and chemical cycles. So let's begin. In today's lecture we'll look at 5 key core concepts. In concept number 1 we'll look at the Earth's climate, how it varies by latitude and season. In concept number 2 we'll look at the distribution of terrestrial biomes, how they're controlled by climate and man-made disturbances. In concept number 3, we'll look at aquatic biomes, their diversity and how they cover most of the Earth. In key concept number 4, we'll look at how interactions between organisms and the environment limit the distribution of species. In key concept number 5, we'll look at ecological change and evolution and how one affects the other over long and short periods of time.
Before we start with ecology, we must define what it is. So what is it? Ecology is the study of the interactions between organisms and the environment. The interactions studied by ecologists can be organized into a hierarchy that ranges in scale from single organisms to the planet. So at the bottom of this biological hierarchy is organismal ecology. Now this includes the subdisciplines of physiological, evolutionary and behavior ecology and is primarily concerned with how an organism's structure, physiology and behavior meet the challenges posed by its environment. So the next biological level is population ecology. So what's that? Well, a population is a group of individuals of the same species living in an area. Population ecology analyzes factors that affect population size and how and why it changes through time. So the next level above population ecology is community ecology. So what's a community? A community is defined as a group of populations of different species in an area. Community ecology examines how interactions between species such as predation and competition affect community structure and organization.
The picture on the left of the slide shows a zebra, a flock of flamingos and a herd of wildebeest. But look carefully. Where is the predator in the picture? Can you see the crocodile?
So the next biological level is ecosystem ecology.
An ecosystem is defined as a community of organisms in an area and the physical factors with which those organisms interact. Ecosystem ecology emphasizes energy flow and the chemicals cycling between organisms and the environment. Higher up in the ecological hierarchy is landscape ecology. A landscape or seascape is a mosaic of connected ecosystems. So these ecosystems are all connected. Research in landscape ecology focuses on the factors controlling exchanges of energy, materials and organisms across multiple ecosystems.
Now the final level in the biological hierarchy is the global ecology. The biosphere is the global ecosystem, the sum of all the planet's ecosystems and landscapes. Global ecology examines how the regional exchange of energy and materials influences the functioning and distribution of organisms across the biosphere. So how do latitudinal variations in sunlight intensity affect global climate patterns?
So let's have a look at latitudinal variation in sunlight intensity. Now the Earth's curved shape causes latitudinal variation in the intensity of sunlight. Because sunlight strikes the tropics, those regions that lie between 23.5 degrees north latitude and 23.5 degrees south latitude most directly, more heat and light per unit of surface area are delivered there. At higher latitudes, sunlight strikes Earth at an oblique angle and thus the light energy is more diffuse on Earth's surface. Now, in addition to latitudinal variation, the sun's activity plays a major role in the amount of light striking the Earth. Currently, our sun is in a solar minimum. This can be seen in the image on the bottom of the right-hand side of the screen. Now, the intense solar radiation near the equator initiates a global pattern of air circulation and precipitation, so it starts at the equator. High temperatures in the tropics evaporate water from the Earth's surface and cause warm, wet air masses to rise and flow towards the poles. The rising air masses release much of their water content, creating abundant precipitation in tropical regions. The high altitude air masses, now dry, descend towards the Earth, absorbing moisture from the land and creating an arid climate conducive to the development of the deserts that are common at latitudes around 30 degrees north and south. Some of the descending air then flows towards the poles. At latitudes around 60 degrees north and south, the air masses again rise and release abundant precipitation, though less than in the tropics. Some of the cold, dry, rising air then flows to the poles, where it descends and flows back towards the equator, absorbing moisture and creating the comparatively rainless and bitterly cold climates of the polar regions. The Earth's global patterns are determined largely by the input of solar energy and the planet's movement in space. The sun's warming effect on the atmosphere, land and water establishes the temperature variations, cycles of air movement and evaporation of water that are responsible for dramatic latitudinal variations in climate. Now, as the Earth rotates on its axis, land near the equator moves faster than that at the poles, deflecting the winds from the vertical path shown in the previous slide. Now, cooling trade winds blow from east to west in the tropics. Prevailing westerlies blow from west to east in the temperate zones. Temperate zones can be defined as the regions between the Tropic of Cancer and the Arctic Circle, and between the Tropic of Capricorn and the Antarctic Circle. So what is the difference between weather and climate? Weather and climate are terms that are related but do not mean the same thing. Weather is the state of the atmosphere at a given time and place. For instance, this would be if it currently is sunny today, what the temperature is, or if we are expecting clouds and rain tomorrow. Weather is what is forecasted from day to day. Climate, on the other hand, is the long-term average of the weather of an area. This would refer more to the type of weather you could expect at different times of the year. Normally, the northern US can expect snow or below freezing temperatures in winter and warm summers with some humidity. These expected weather patterns, together with other factors, make up our climate, which generally remains unchanged over the span of a human lifetime. Now, there are 4 abiotic factors: temperature, precipitation, sunlight and wind. These constitute the major components of climate. Now, climate factors, particularly temperature and water availability, have a major influence on the distribution of terrestrial organisms. Let's consider seasonality. Now, the Earth's tilted axis of rotation and its annual passage around the Sun causes strong seasonal cycles in middle to high latitudes.
In addition to variations in solar radiation, the changing angle of the Sun over the course of the year also affects local environments. For example, the belts of wet and dry air on either side of the equator move slightly northward and southward as the Sun angle changes. This produces marked wet and dry seasons around 20 degrees north and 20 degrees south latitude, where many tropical deciduous forests grow. So, do you know the difference between weather and climate? Let's ask some Americans.
Hi, Mr. President. Today I want to tell you about climate change. Don't get angry, Mr. President. It's just science. Like gravity. You don't get mad about gravity, right? Well, climate change is just like that. It's caused by the greenhouse effect, which was first demonstrated by John Tyndall way back in 1859. That's before even you were born. In a greenhouse, sunlight shines in and warms up the air. When the energy tries to go out, it gets trapped by the glass, warming the air inside even more. Woo, that's hot. Well, The Earth's atmosphere works just like a giant greenhouse. It's huge. Sunlight gets reflected back by water vapor and also by greenhouse gases like carbon dioxide and methane.
So the more greenhouse gases you add to the atmosphere, the more energy gets trapped. Makes sense, right?
And we've been adding a lot of greenhouse gases lately. Look! All that extra trapped energy is already causing higher temperatures, melting ice, more extreme weather, rising sea levels, drought, and a lot more things that'll make Earth a pretty tough place for kids like your son Baron and me to live.
And even though it's cold where you are, that doesn't mean the globe isn't heating up. What you are experiencing is weather. Weather is what happens today. Climate is what happens over the long run.
And that's called climate change. You can learn more about it at climate.nasa.gov. And if there's anything else you need to know, just ask. You're welcome.
So what causes seasonal variation in sunlight intensity? The Earth's tilt causes seasonal variation in solar radiation intensity because the planet is tilted on its axis by 23.5 degrees relative to its plane of orbit around the Sun. This causes the tropics to experience the greatest annual input of solar radiation. The seasonal variations of light and temperature increase toward the poles. Now, because the Earth is tilted, different latitudes receive different sun angles throughout the year. During summertime in the northern hemisphere, the Earth is tilted so that the northern hemisphere is angled more directly at the Sun. It receives more direct sunlight and is warmer. At the same time, the southern hemisphere is angled away from the Sun, so it receives less direct sunlight and experiences winter. The axial tilt does not change throughout the year, but as Earth travels to the other side of the Sun, the opposite hemisphere is angled toward the Sun and the seasons change. At the fall and spring equinoxes in mid-September and mid-March, the axis is pointed neither toward nor away from the Sun, and the northern hemisphere and southern hemisphere receive the same amount of sunlight. Day and night are of equal length at this time. After the equinox, the days begin to get shorter in one hemisphere and longer in the other. At the summer and winter solstices on the 21st or 22nd of June and December, the days are at their longest or shortest respectively. The summer solstice in the northern hemisphere, June 21st or 22nd, is also the winter solstice in the southern hemisphere and vice versa.
So if you are interested in how the Earth's axis of rotation affects seasonality, click on the link below.